Alright guys, today we're going to talk about solving equations with variables on both sides of the equation. Okay, now what's nice about this is the goal and the rule are still the same. We still ultimately want to isolate the variable on one side of the equation, and whatever we do to one side we have to do the same thing to the other to keep the equation in balance. Now, since the goal is the same, you want to have the variable on just one side. Remember, we want to isolate on one side. We can't have it on both sides. So to get it just on one side, we're going to use some inverse operations again. And then there is often, you can really get rid of either variable on either side, but it's often easier to collect the terms with the variables on the side with the larger variable. But you don't have to. You can technically get rid of either, but it's often easier to get it on the side that already has more of the variables. Now, and before you get it all to one side, you're going to want to simplify both sides before, that's really important, before getting the variables to one side. All right. All right, now we've got all the basics. Let's actually do some examples together. In this first problem, we have 4x plus 5 equal to 2x plus 9. Now, if you look, each side is simplified. 4x plus 5 is fully simplified. There's no like terms to combine. There's no parentheses to get rid of. Same with 2x plus 9. So what we want to do next is we want to get the variable on one side. We have 4x on the left side and 2x on the right side. So one of those two we have to subtract. There's usually one that's easier to subtract. To me, it looks like it's going to be easier to subtract 2x. Okay? Because if we subtract 2x from the right-hand side, that'll cancel, leaving us with just 9. But whatever we do to one side, we have to do the other. So we have to subtract 2x on the left-hand side. And you notice I'm lining up like terms. I can only subtract 2x from the 4x. So 4x minus 2x gives us 2x. And that plus 5 we haven't touched, so we're going to leave that alone. And now we have a pretty simple two-step equation that we've done before. Okay, we still want to isolate variables, so we're going to start with our adding or subtracting. So we're going to subtract 5 from both sides. We get 2x equal to 4. Divide by 2, and we get x equal to 2. And again, you might always want to do a quick mental check. Plug that 2 in the left-hand side. 2 times 4 is 8, plus 5 is 13. Plug it in the right-hand side. 2 times 2 is 4, plus 9 is 13, so we know we did it correctly. And again, technically you can you could have gotten rid of the 4x, but you would have dealt with a little bit more negatives. Okay, let's look at example number 2. We have 6x plus 22 equals negative 3x plus 31. Again, each side is simplified, so we don't have to worry about simplifying. And we have a 6x on the left side and a negative 3x on the right-hand side. To me, the easier one to get rid of would be that negative 3x, because minus a negative 3x is the same as plus 3x. That, to me, looks like the easier thing to do. So I'm going to add 3x and add 3x to both sides. And you notice, again, I'm lining up like terms. And 6x plus 3x would give me 9x plus 22. And this would equal 31. And again, if I was doing properties here, even though there's x's involved, this would be that addition property of equality that we just used. Now we can just finish isolating our variable. We could subtract 22 from both sides. We get 9x equal to 9. Divide by 9. And we get x equal to 1. All right. Let me move this up so we can look at example number 3. All right, in example number 3, we have 4 times the quantity x minus 5 equals 4x minus 20. Now we have a parenthesis on the left-hand side, so we have to do some simplifying to both sides first. So when I distribute that, use distribute property, distribute that in, I do 4 times x and get 4x. And then 4 times 5 gives me minus 20. So I have 4x minus 20 equals 4x minus 20. Now, hopefully you might realize something right now here, that both sides are exactly the same. Because there's something in a special that's going to happen here. We have a variable on both sides. We'd have to cancel one of them. Say we wanted to cancel this 4x on the right-hand side. We'd have to subtract 4x. And if you notice what happens, when I subtract 4x here, I get the x's cancel on both sides, and I get negative 20 equal to negative 20. Now, this is a true statement. Now, when this works out, the variables cancel, and it's a true statement, what's going to happen is what's going to be true is all real numbers will work. Because when you end up with the variables canceling and a true statement, it means that any number you plug in will work. If I plugged in, say, 5 over here, 4 times 5 is 20, 20 minus 20 is 0. I'm going to get the same thing on the left-hand side. So the answer to this would be all real numbers. Okay? That's very important, though. That has to be a true statement if the variables cancel out. Now, if we look at number 4, okay, we have 3x minus 9 equal to 3x plus 10. Each side is simplified already, so we want to get the variable on one side. And we go to do that, we would subtract 3x and subtract 3x. And here you notice the variables will cancel on both sides, but in this case I get negative 9 equal to a positive 10. Now, that's not true, or that's a false statement. So in this case, because even when the variables cancel out, there'd be a false statement. There is no solution for this. There is no number that will work to make this equation true, because it's really not in balance. Okay, so make sure you know the difference between when there's a all real numbers will work or there's no solution. All right. Now, let's move this up and look at a couple more examples. All right, in example 5, we have 1/2 of 12 minus 2x minus 4 equals 5x plus 2 times x minus 7. We definitely have to do some simplifying on each of these sides before we can even think about moving the variable to just one side. I start with my distributive property here, and left-hand side, 1/2 of 12 would be 6. Now, if you wanted to change this to plus and negative, you could look at 1/2 of 2x would be a negative 1x or negative x. Minus 4, we might want to put as plus and negative 4. Equal to, we're going to have 5x. I'm not touching that 5x yet because I got to do the distributive first. So I'm going to have plus 2x, and we might want to think of this as like plus a negative 7. So that'd be plus a negative 14. Okay, now I want to do some combining like terms. I'm not fully simplified yet, because like on the left-hand side I can combine the 6 and negative 4. So I have negative 1x plus 2 equal to, and on the right-hand side I can combine the 5x and the 2x and get 7x plus a negative 14. Now in this case, looking at both, now I've got each side simplified. I have a negative 1x on the left-hand side, a 7x on the right-hand side. To me, the easier one to cancel would be the 1x, because I can just add 1x to both sides. So I get 2 equal to 8x plus a negative 14. And now I want to isolate the variable, so minus a negative 14. Do my adding or subtracting first, which is like plus a positive. And I get 16 equal to 8x. Divide by 8, I get x equal to 2. All right. Let's look at number 5, or number 6. All right, number 6. Again, I have to do some simplifying first. On the left-hand side, I'm doing 2/5 times 10. Now, the 10 and the 5 would cancel, leaving me with 2. So 2 times 2 would give me 4x. Plus the 5 and the 15 would cancel, leaving me with 3. Oops. So that would give me a 6 left over. Equal to, now I've got some subtractions here, so I'm going to change them to plus and negative to make sure I get the sign right. So here I'm going to have 18. It'd be plus a negative 4x and plus a positive 12, because the negative 4 times a negative 3 would make it a positive 12. Now, I'm not fully simplified on the right-hand side here yet. I can combine the 18 and the 12. I'm done simplifying the left-hand side, so I'm just going to bring that down. Here I like to put my variable first. Just habit, I tend to put it first. 18 plus 12 is going to give me 30. All right, now I'm going to get the variable on one side. Now I have a positive 4 and a negative positive 4x and negative 4x. But I can cancel out on this right-hand side this negative 4x by adding 4x. Minus a negative 4x is the same as adding 4x. And I do get 8x plus 6 equal to 30. And I'm going to subtract 6. I get 8x equal to 24. Divide by 8. And I get x equal to 6. Oh, excuse me. Yeah, 3. Hello. Let me get that right. All right. And you notice, guys, how I'm showing work on all my steps. Okay, let's flip over to the other side and look at the word problem. Okay, let's look at example number 7. It says you have 2 choices for places to rent video games. At video stores, it costs $8 to rent a video game, but membership is free. And at Video Game Club, it costs only $3 to rent a video game, but there's a yearly membership fee of $50. Which place is more economical and why? Well, what you really have to do here is you kind of have to kind of compare the two. I mean, video stores, it looks like the important information is it's $8 to rent, but membership is free. At the Game Club, it's $3 to rent a video game, which seems like a lot cheaper, but there's also a membership fee here. So to really be able to compare these two, we kind of need to know, well, when do they cost about the same? Like, how many would you have to really rent to cost the same? That would cost the same. And then from there, you can decide which would be more economical. It kind of depends on how many you rent. So let's kind of compare them. Let's think of, you're going to make an equation. And this side, left-hand side of the equation, let's make it at the video store. All right, we want to find out when it's going to be equal to the Video Game Club. Okay, because if we know when they're equal, we can kind of then compare and look at which one's better for us. Well, to kind of have an algebraic expression to represent video store, it costs $8 to rent a video game. Okay, so let's say, so it's always going to be 8 times however many video games you rent. So let's make the number of video games we rent X. Okay, whereas when it will be equal to video game, now Video Game Club, it's $3 times however many you rent. But it's also going to be an extra fee of $50 per year. Okay, so 3x plus 50 is a good way of showing that. So here we have an equation with variables on both sides. Let's isolate that variable and solve for x. How many video games would be equal no matter which one you belong to? So I'm subtracting 3x from both sides because that seems like the easier one to subtract. I get 5x equal to 50. Divide by 5, and I get x equal to 10. So if you rented 10 video games in a year, it wouldn't matter which club you would belong to, all right, you would, it would be wash, it would be equal. So let's look at one below. Let's look at what would it cost if, say, you rented 9 video games. Let's say you did 8. If the video store, you do 8 times 9, it would cost you 72. What would it cost a video game if you did, Video Game Club if you did 9? Well, you'd have to do 3 times 9 plus 50, which would be 27 plus 50, which would give you $77. So it looks like if you did less than 10, the video store would be a better buy. Let's see if we went over 10. Let's pick, say you did 12. According to this, you do 8 times 12 for the video store. 8 times 12 would cost you $96 if you rented 12 video games in a year. Let's see what it would cost for Video Game Club if we did 3 times 12 plus 50. 3 times 12 is 36 plus 50. It would cost you just $86. So if you were going to rent more than 12 in a year, it looks like Video Game Club would be the better buy. So which would be the better buy depends on kind of around this kind of where they would be equal. If you would do less than 10, you want to go with the video store. If you would rent more than 10, you'd want to go with the Game Club. All right, guys. So you want to work on your homework, and hopefully this gave you enough of a preview to give you a good idea of how to solve equations with variables on both sides. We'll work a little bit more with it again tomorrow as well.